Hey folks, what's going on? My name is Dr. Plord or Professor Plord or Professor Lyrical for those of you who choose to use that. You can check me out at professorlyrical.com if you're not sure what I'm talking about yet, or at Prof Lyrical at Twitter. That's PROFLYRICAL. But I'm here to show you some patterns and functions, what we mean by that, and basically what a course in patterns and functions will essentially be about. So behind me here, you see a graph I just drew. I just did a 6x6. Don't forget that X is the horizontal axis and Y, like sky, is in vertical. Positives being up or positives being right, left being down, or left being negative or down being negative. So we do all of our coordinates, such as like this one right here. That would be 3, 2. If you notice, this is 1, 2, 3 over. 1, 2 up, so it's positive 3, 2. The middle point right here would be the origin. I just drew a little arrow there so you can see its coordinate would be 0, 0. This was created by Rene Descartes. It's called the Cartesian coordinate system. It's pretty cool because what it does is it gives us a chance to think about two dimensions, really. We're going this way and this way, so we can talk about how far over we are and how far up or down we are, which is pretty cool. If we want to do a negative point, let's say here, that looks like 2 over and 1, 2, 3, 4 up. So we'd say negative 2, 4. What's cool with patterns and functions is we start out with just basic straight lines, and we can move to curvy lines and stuff that's a little bit more nuanced. But basically the deal is we should be able to take any 2 points and connect them with a straight line, and we can find out some things, some properties about those points and the line that's between them. And we do that by mainly looking at slope, or which is sort of a rate of change between 2 points, okay? So here we see negative 2, 4, and here we see 3, 2. What we want to do, we want to talk about what is the difference in, I just drew a triangle there to help, what's the difference in height of this point and this point, and what's the difference in length across? And we compare those by first looking at the order I said, the height over the length that we've traveled, okay? So if we stay here as a starting point, negative 2, 4, and ending point 3, 2, we can think of each of these ordered pairs as x, y. That's the order we're going, right? X, y. Sometimes you'll see sub 2 and sub 2 there, meaning that this is our second pair that we're looking at. This is our first one, okay? So this is x sub 2, y sub 2. It just means the second point, really, point 2 and point 1, okay? No need to really write 1 and 1 there if it's the first point, but you'll see others sometimes written like that. No subscripts just mean which point they belong to, nothing else. I know it can look weird. We want to just compare these, and we do it by slope. So what we do is we subtract the y values and subtract the x values. By subtract, we just mean we find the difference. Difference meaning subtract. So 4 minus 2, I'm going to do the work down here, all over negative 2 minus 3. That negative is important, that's in the negative 2. And then we just do the math. 4 minus 2 is 2. Negative 2 minus 3 is negative 5. So that means this has a slope of negative 2/5, okay? It doesn't matter if the negative's here or here, just one negative in the fraction creates a negative value. 2 negatives would be the same as a positive. So what we're saying here is that this point to this point, as we travel from here to here, we're going down a slope of negative 2/5. And that's often written as the letter M, just to denote slope. That's another story why somebody picked M, but often we see equations in the form of y equals mx plus b. B being the y-intercept, meaning the height that the line crosses the y-axis. You can kind of take a guess here. This looks like 0, let's see, 1, 2, 3. Looks like that line crosses at positive 3. So some kind of equation, we could expect this to be something like y equals, put our slope here, negative 2/5. That's where it goes, wherever that m is. With x and y are always just left blank as x and y when you're done writing these, plus some b value. It could end up being a negative. We need to calculate where that is, but if it's above 0, it'll be a positive value. If it's below, it's a negative. And we can kind of figure that out too. One of the key things in patterns and functions and in algebra in general is asking you to figure out what would be the y-intercept of an equation like that. So what we'd start out with is we would say, hey, we know the slope. Now if we just have any other point, we can calculate for this b if we plug in an x and a y. So we can use either one of these x and y values as a pair, plug it into this x and this y to do that algebra to solve for the b. And that's why this is a main kind of algebra tool. We see this in algebra a lot so that we can practice calculating something when we have a few variables and we're trying to find a fourth. So we have one variable, the m. we're going to take an x and y pair, let's take these because there's no negatives, might make it easier, and plug them in for y and x respectively. So remember, this is x, this is y. So we're going to take the 2 and put it here. 2 equals negative 2/5 times whatever the x value is, in this case it's 3, plus some b that we're going to solve for. So if we do a little math here, we'll get negative 6/5 if we multiply this. So 2 equals negative 6/5 plus b. Let me write that up here. 2 equals negative 6/5 plus b. Now if we add 6/5 to both sides, in other words, get all the numbers on the left and keep the letters on the right, we have essentially 6/5 plus 2 equals b. A nice trick when you're adding fractions is to write something over itself to be a value of 1. So if we want to think of 6/5, we can think of 1 as just 5/5, but since we need 2, we can just double the top and make it 10/5. So watch this, 6/5 plus 10/5, which is another way of saying 2, equals b. So that's going to be 16/5 equals b. I remember we said an estimate would be that this looks like it's about a 3, but we can't trust our eyes until we do the math and see what we actually get. So really it's 16/5, which is like 3 1/5. So final answer here would be y equals negative 2/5 x plus 16/5. And now I'm just going to check my work to make sure it makes sense, okay? So let's see, it's going downhill, so the slope should be negative. And by downhill, we mean from the origin here, right? The origin being located here, going this way, right? Going to the right. That would be normally like how we're walking or reading from left to right. We say, is it going uphill or downhill? So it's going downhill, so we should say a negative slope, negative for downhill. We do have that. Is it steep? Is 2/5 steep? Well, I guess it depends on how you define steep. More than 1, I would say, is certainly steep, because a traditional slope of if you look at this right angle and you cut it in half, you have a 45-degree angle. 45-degree angle is a slope of 1, where the rate for length and the rate for height is changing at the same rate. Anything greater than that would be a slope of 1 or higher. Like a slope of 2 would be really steep, 3, 4, 5, and so on, all the way to almost infinity. So y equals 2/5. Okay, so that's not quite a 45-degree angle, doesn't look like, but it's pretty close. Maybe you can't tell exactly, but I can tell that it's a somewhat flat slope, not as flat as a flat line, but it's approaching a slope of 1, of negative 1. Plus 16/5, does that look about 16/5? Yes, it does. It looks like a hair below the line I just drew freehand. So that essentially, in a nutshell, I guess, is basically the beginnings of how you even talk about patterns and functions. We need to first find 2 points, connect them, figure out a slope for that line, and then be able to write an equation for that line, which we've done in the standard, well, I should say in the slope-intercept form, which is the standard form you typically use, not to be confused with general or standard form, which is a slightly different variation of that by putting the x's and y's on the same side and putting the constant on the right-hand side. We can manipulate that with a little bit of algebra, but for now, that's a good amount. Just wanted to show that to you, give you an introduction of some of the tools you need to have in your toolkit to be able to look at patterns and functions. So y equals mx plus b, slope is defined as the change in y over the change of x, which we sometimes see in textbooks like this. Change in y over change of x equals m, that's our slope. Any 2 points, plug in the coordinates, find the slope between them, and set up your equation of your line, and we go on from there. All right, thanks. Check me out. Peace.